Betelgeuse, one of the most recognizable stars in the night sky, has been captivating scientists and astronomers for centuries. Known for its bright, reddish glow and as one of the largest stars visible from Earth, Betelgeuse sits within the constellation of Orion. Located approximately 640 light-years away, it's a red supergiant nearing the end of its life, a phase in a star's life cycle that often brings about drastic and sometimes unpredictable changes. In recent years, astronomers have noticed unusual behavior from Betelgeuse, including a peculiar dimming that puzzled scientists and raised questions about the star's future. This has led researchers to explore the possible causes behind Betelgeuse's uncontrolled shaking, an observation suggesting the star may be closer to a supernova than previously thought. In 2019, Betelgeuse's brightness began to fade dramatically, sparking global interest and speculation. As a variable star, Betelgeuse's brightness does fluctuate, but this dimming was unlike anything observed before. The star, which is typically the second brightest in Orion, appeared to fade by over 60%, surprising both amateur and professional astronomers alike. This dramatic reduction in brightness gave rise to theories that the star might be nearing a supernova, a powerful explosion that marks the end of a massive star's life. However, as Betelgeuse eventually returned to its normal brightness, scientists were left with questions about the true cause of this sudden change. Following the 2019 dimming event, scientists conducted numerous studies to understand what had happened. One explanation was that a massive ejection of material, or stellar burp, had caused a cloud of dust to form around Betelgeuse, temporarily blocking its light from reaching Earth. This phenomenon isn't unusual for red supergiants, which are known to shed material frequently as they near the end of their life cycle. However, the sheer scale of this ejection was unprecedented, leading scientists to investigate further. Observations revealed that Betelgeuse had expelled a significant amount of its outer layers into space, creating a cloud of material that absorbed and scattered the star's light. As astronomers continued to monitor Betelgeuse, they began to notice another intriguing behavior, what some described as an uncontrolled shaking. This was actually a series of complex pulsations, where the star's outer layers expanded and contracted in irregular rhythms. These pulsations have increased in both frequency and intensity, leading scientists to wonder if they might be indicative of an impending supernova event. Pulsations are common in red supergiants as they reach the end of their life, but Betelgeuse's erratic and intensified behavior has pushed researchers to reconsider their models of how such stars die. One major reason Betelgeuse's activity is so fascinating is that a supernova occurring relatively close to Earth would offer a unique observational opportunity. Most supernovas we observe happen in distant galaxies, making it difficult to study them in detail. If Betelgeuse were to explode, it would become incredibly bright, likely visible even during the day, and offer scientists an unprecedented chance to study the death of a massive star up close. A supernova occurring within a few hundred light-years from Earth would allow researchers to test theories about star explosions and better understand the life cycles of massive stars. Although Betelgeuse's pulsations and recent outbursts have raised hopes of witnessing a nearby supernova, astronomers caution that it could still be thousands of years before this event occurs. Stars like Betelgeuse don't adhere to predictable timelines, and while it might seem like the star is in its final days, these processes can take considerable time in astronomical terms. That said, the unusual dimming and shaking behaviors are prompting scientists to keep a closer eye on the star. New observations have suggested that Betelgeuse may be entering a more volatile stage, with further ejections and pulsations likely in the coming years. In addition to the prospect of a supernova, Betelgeuse's recent activity provides valuable insights into the late-stage evolution of red supergiants. These stars are much larger than the Sun, with Betelgeuse alone estimated to be about 1,000 times its size. As red supergiants approach the end of their life, they undergo extreme internal changes that can lead to erratic behavior on the surface. Betelgeuse's current shaking may be the result of these internal changes, as complex processes involving nuclear fusion, magnetic fields, and convective currents begin to destabilize the star. This shaking is likely due to the complex interplay of energy and pressure as heavier elements fuse in the core. Another exciting possibility is that Betelgeuse's recent behavior could indicate the presence of a neutron star, or other exotic objects within its core. Some astronomers speculate that if Betelgeuse were to collapse, it could leave behind a dense remnant, such as a neutron star or possibly even a black hole. If Betelgeuse does go supernova, the core collapse could yield fascinating data on the formation of these exotic remnants, helping scientists learn more about how black holes and neutron stars are born. This would not only advance our understanding of stellar evolution but also potentially offer insights into gravitational waves and other phenomena associated with massive cosmic events. Interestingly, Betelgeuse's strange activity has also sparked a wave of public interest in astronomy. The star has captured the imagination of people worldwide, and many are eagerly following updates from observatories and space agencies. In many ways, Betelgeuse's story underscores how dynamic and unpredictable the universe can be. As more people become interested in the sciences, stars like Betelgeuse serve as powerful reminders of the natural wonders that exist beyond our planet and the mysteries that remain unsolved. While a Betelgeuse supernova might seem like an exciting prospect, scientists are careful to emphasize that such an event poses no threat to Earth. At a distance of roughly 640 light-years, Betelgeuse is far enough away that even a massive supernova wouldn't harm life on our planet. However, the explosion would likely create a dazzling display in the night sky, potentially outshining the full moon for a few weeks or even months. This would provide astronomers with valuable data, not only about the supernova itself but also about the interstellar medium, as the shockwave and ejected materials interact with surrounding space. The study of Betelgeuse and its peculiar behavior is a reminder of how much we still have to learn about the cosmos. Even though our understanding of stars and their life cycles has advanced dramatically in recent decades, events like the 2019 dimming reveal gaps in our knowledge. By continuing to observe and study Betelgeuse, astronomers hope to refine their models and predictions for massive stars, which play crucial roles in the formation of elements and the evolution of galaxies. The data gathered from Betelgeuse's shaking could lead to breakthroughs that not only deepen our understanding of red supergiants but also improve our ability to predict and interpret other cosmic phenomena. In recent years, astronomers have employed advanced technology to monitor Betelgeuse closely, using instruments that detect changes in brightness, spectrum, and even shape. These observations reveal a star in flux, shedding mass, expanding, contracting, and pulsing in ways that challenge conventional models. The latest data suggests that Betelgeuse's outer layers are not only shaking but also rotating faster than expected, possibly due to interactions with a binary companion or other internal factors. These complex motions hint at the internal chaos within the star as it approaches the end of its life, with each tremor potentially a precursor to the final, explosive act. Betelgeuse has become a symbol of both the progress and the mystery inherent in astrophysics. On one hand, we have advanced tools and technologies capable of observing stars in ways that were once unimaginable. On the other, Betelgeuse's recent behavior highlights the unpredictable nature of the universe and our ongoing quest to understand it. Despite our best efforts, nature often surprises us, revealing complexities that challenge existing theories and fuel new lines of inquiry. In a sense, Betelgeuse's future is a mirror of humanity's own journey to understand the universe. As we watch and wait, the star continues to perform its cosmic dance, offering both hints and puzzles. Whether or not it explodes in our lifetime, Betelgeuse serves as a beacon of the wonders that lie beyond Earth, a reminder that, in the grand scope of the cosmos, there is always more to explore, learn, and marvel at. For now, astronomers continue to monitor Betelgeuse, documenting every shake, pulse, and flare in hopes of deciphering its mystery.